Electronegativity and bond character. We are also going to define electron affinity. So let's start there. So electron affinity, this is the attraction of an atom for its own electrons. And when you look at the periodic table, the trend is that noble gases really have a pull on their electrons. They are very stable. They have a completely filled outside shell or energy level. And so it's going to be very attracted to those electrons. So your noble gases are very high. Also, your nonmetals, they are also high. When you look at metals, metals tend to be large atoms. And so because of the distance between the nucleus and those outer electrons, they tend to have low electron affinities. Again, attraction for its own electrons. Electronegativity is something different. This is the attraction of an atom for electrons in a bond. So now we're talking about bonding. And when you look at bonding, you're looking at those electrons that are shared or transferred between two atoms. Metals have a very low electronegativity. Nonmetals have a very high electronegativity. And noble gases do not have a electronegativity. How come they do not have an electronegativity? And the answer is electronegativity has to do with bonding, and noble gases do not bond, so they do not have electronegativity. The atom that has the highest electronegativity is fluorine. So it is the king of taking the electrons in the bond. All right, so here is a chart that summarizes some of the periodic trends that we've talked about. So we've talked about electron affinity, again, attraction of an atom has for its own electrons, and we see that it follows the trend for radius. So helium is our smallest radius or our smallest atom. Francium is our largest. And so if it's a smaller atom, the nucleus's attraction for its electrons or its electron affinity is going to be very, very high. It also follows the same trend, that size, with ionization energy. Ionization energy, taking an electron away from the atom and making an ion. The smaller the atom, the harder it's going to be to take that electron away. We could also add electronegativity because that seems to be missing. Again, electronegativity is the attraction of electrons in a bond. And so we see that the nonmetals are very, very high as far as electronegativity, and your metals are very, very low for electronegativity. We have not talked about metallic character before, but that really is just the difference between a metal and a nonmetal. So recall you have that little stair step dividing the nonmetals from the metals. And so the closer you are to the left-hand side of the periodic table, then that's the metal side of the periodic table. And then that upper right-hand corner, those are your nonmetals. Let's talk about ionic and covalent bonding. It's also called bond character. Covalent bonding has to do with sharing electrons. And electrons are shared when they have similar electronegativities. Covalent bonding occurs when a nonmetal bonds with a nonmetal. What happens when we have a metal with a nonmetal? Well, that we would call an ionic bond. So the nonmetal will have a very high electronegativity, and because of that, it's going to take the electrons in the bond. So it's more powerful. So it will actually strip the metal of its valence electrons. And so this causes a change in charge. So in this picture, I have ionic bonding. Sodium has very low electronegativity, and our nonmetal over here, chlorine, has a very high electronegativity. And it's so high that it's actually going to strip and take the metal's electron. And so this creates a negative cation. Excuse me, I said that wrong. This creates a negative anion and a positive cation. And what happens when you have opposite charges? They're going to attract. And this positive with negative sticking together, that's an ionic bond. That electrostatic attraction is called an ionic bond. I failed to mention this picture right here. This is covalent bonding. This is two oxygen atoms. And because oxygen atoms, it's a nonmetal with a nonmetal. And in fact, this one, it's going to pull exactly evenly because it's the same element. And so they end up sharing those electrons. So instead of transferring, they will share. I already kind of explained this, but you can stop the video and read it if you're interested. Let's go through and classify each of these atoms that are bonded together as a covalent or an ionic bond. So again, covalent sharing electrons, they will be very similar in electronegativity. Ionic bonds, they will be very different. So number one, we have a metal with a nonmetal, and they will be very different. The nonmetal will be higher in electronegativity than the metal, and so because of that, it will strip that electron away from the metal, and we will get an anion and a cation, and this would be ionic. This next one, this is also a metal and a nonmetal. And so again, the nonmetal will strip that electron away, and you'll have that electrostatic attraction that we call ionic bonding. Number three, we have a nonmetal with a nonmetal. They are going to pull about equally. They are right next to each other on the periodic table or pretty close, and so they will end up in sharing electrons. This is a covalent bond. This next one, we've already looked at this example, two oxygen atoms. It is a nonmetal with a nonmetal, and because they're going to be pulling equally, this will be sharing electrons or a covalent bond. Go ahead and stop the video and answer 5, 6, and 7. See if you can do this, and then we'll check the answers. Okay, we're back. We have aluminum as a metal, oxygen is a nonmetal, so they're very, very different in electronegativities, and so that nonmetal will take the electron and we will have ionic bonding. Sulfur and chlorine is a nonmetal with a nonmetal, and so because they are alike, they will share. This is covalent bonding. And the last one, we have a metal with a nonmetal. So very different in electronegativities. That nonmetal is going to pull more, creating an anion when it strips the electron away from the metal, and this will be ionic bonding. How did you do? Another way you can determine ionic and covalent is you can look on the back of your periodic table, and that white one that I gave to you at the beginning of the year, and you can look up the electronegativity number. So fluorine was assigned the electronegativity number of about 4. And so everything is compared to fluorine. So you can look up that number. Again, it's on the back of the periodic table, and it's the upper right-hand black number. And so that's the electronegativity value. You can look up both atoms that are in the bond, and you can subtract their electronegativity powers. And if you end up with a difference of 1.7 or greater, you would classify that as ionic. If it's less than 1.7, you would classify that as covalent. And recall again that covalent is nonmetal with a nonmetal. Because they're going to be very, very similar, their difference in electronegativity is going to be very low. Ionic, they'll be very different because nonmetals are more powerful, and they will take the electrons in the bond, making an ionic bond. So for an example here, we can look up sodium and chlorine. We find that chlorine is 3.16, and sodium, I think it's 1.8. Forgive me, I don't have my periodic table. But when we go and we subtract it, we end up with a difference that's about 2.23. And looking at that difference, we see that it's greater than 1.7. We find that it is ionic. And hey, we already know it's ionic anyway because this is a metal bonded with a non-metal. So we would just want to use this math method if we were unsure. Like maybe we had a metalloid bonded with a nonmetal, and so we're unsure of what that situation would be. So we could look up the number value and subtract. Again, if it's a great difference, so bigger than 1.7 or equal to 1.7, we would call it ionic. Let's look at sulfur here. So chlorine is 3.16. And forgive me, I don't remember what sulfur is, and I don't have a periodic table. I think it's like 2.3. I do remember that the difference is zero point 0.6. Okay, so this would be a covalent bond because it's again very similar. So that's a low difference between the two. So they're going to be sharing electrons in that. So again, subtracting their electronegativity numbers is a way to quantitatively determine whether it's ionic or covalent. So here is, again, on the back of your periodic table, it will list it individually. This is just a table that shows that, again, fluorine is a 4 in electronegativity, and you see how that electronegativity increases as you go up a family and as you go across from your metals to your nonmetals. So except for a bond between two nonmetallic atoms of the same element, every bond has some ionic and some covalent character. So for example, if we were to look up a 1.7 difference, we would find that it would have a 51% ionic character. And you can find this chart again at the back of your periodic table, the very top of your periodic table. There's a little skinny chart, and it shows that ionic bonds are never purely ionic. So they're going to be a mixture of ionic and covalent. So there's an arbitrary cutoff point where we say, hey, it's going to be transferring electrons, not sharing. And so that, again, arbitrary cutoff point is 1.7 difference in electronegativity. Above that or equal to that, that would be ionic. Below that would be covalent.